name is Ian Kowalczyk.
My name is Fisher McLeod.
My name is Cameron Champion.
My name is Elijah Padilla.
And this is our scientific inquiry project. In this project, we decided to use elephant toothpaste and try to figure out what catalyst would work best and how much of it would result in the most successful decomposition reaction. So what we're going to first be doing is listing out all of our materials and what processes and methods we'll be using during our scientific method.
For our materials, we use 3 16-ounce soda bottles, hydrogen peroxide, yeast, warm water, dish soap, measuring cups, and lab safety equipment.
For this reaction, we use hydrogen peroxide. Now, hydrogen peroxide is special because you've probably heard that it's an antiseptic. And pretty much what this means is it decomposes into H2O and O2. So, like the normal formula for hydrogen peroxide is just H2O2. So you have 2 hydrogens, 2 oxygens, but then you lose 2 of the hydrogen, or the 2 of the oxygens to make oxygen. So pretty much we're going to be using 100 milliliters of this. So as you can see here, we're going to pour out precisely 100 milliliters. And this is going to be our independent variable for each of these 3 tests that we do.
During this experiment, we will now pour out and measure 100 milliliters of hydrogen peroxide 3 separate times for each of the 3 tests.
Why is that taking so long?
This is a little tiny nozzle.
Cut it open.
No.
Here is the result for each of the test bottles, control A and B, for the elephant toothpaste experiment.
We need approximately 1 tablespoon of dish soap in each container to capture the gas from the decomposition reaction.
Now we'll add a tablespoon of dish soap to each of the containers.
Alright, so now for our control test, as you can see, this is simply just the 100 milliliters of hydrogen peroxide and dish soap. And now I'm going to add some yellow food coloring to see any bubbles. We're going to give that a little bit of a mix. So now if you look in there, you can see some small bubbles forming. That's from the hydrogen peroxide gas. That's from the oxygen.
As you can see, we recorded the temperature for the first
this acts as our
control,
for a test to
and
show
it was
that the
68.3
catalyst will
degrees
speed this
Fahrenheit,
process
which
up of the
translates
gas
to
being
20 degrees Celsius.
So now we're going to pour in a blue food coloring into our first elephant toothpaste mixture for A. And this will be with the 1 teaspoon. And we're going to make this blue. Add a couple drops, mix it around. And this is going to like make all the foam blue.
Now we measure 20 milliliters of warm water to activate the yeast.
1 teaspoon of yeast into the 1 cup of water.
For test A, we add the activated yeast to our mixture.
Now we're going to test the temperature of the reaction product. Oh, that's good.
As you can see on the thermometer, we got a temperature of 91.5, which translates to roughly 33 degrees Celsius.
Teaspoon, tablespoon.
So now we repeat the same process, but now we use 1 tablespoon of yeast.
Now we're gonna add a few drops of food color to test B. Now let's mix it around. Now we add our tablespoon of activated yeast to test B.
So now we're going to insert the thermometer to check the temperature.
This temperature ends up reaching roughly 110 degrees. It's not including the video, but this converts to roughly 43 degrees Celsius.
Keeps going up. We're just gonna speed this part of the video up.
Yeah.
After performing our tests, these are the following results.
The control group had minimal results.
Test A was slower, but not the slowest.
And test B had the fastest decomposition results.
I'm Ian Kowalczyk,
I'm Fisher McCloud.
I'm Cameron Champion.
I'm Elijah Padilla.
and this is the conclusion to our scientific inquiry project over Elephant's toothpaste.
Hooray!
For our conclusion, we found that out of the 3 tests, the control test was the least exothermic as the reaction occurred the slowest. The second best reaction was the test A, as the reaction occurred at an accelerated rate because of the catalyst with the yeast. However, it did not accelerate the fastest. And we found that test B was the most successful, aligning with our hypothesis as that the yeast will accelerate as a catalyst. It'll accelerate the decomposition of the hydrogen peroxide, leading to a faster exothermic reaction. Thank you.